Okay, we're live now.
Crazy.
It's got a few seconds delay, so it might, if you're watching the YouTube or looking at it, you might see that it's a little bit out of sync with what we're seeing, but yeah.
Cool.
So there's a chat on the video, so people that are watching, if you look at the chat, it should be, depending on the layout you have in YouTube, it'll be in a different spot. But typically it's on the right side of the video, so you'll see it there.
Ooh.
If you're on mobile, it's probably underneath.
Pop-up chat. That's cool.
Yeah, it is cool. You can also set it to live, so you can hopefully see everything that's going on. I don't see many participants right now, but that's okay. We just started. There's also a survey there in the description of the video to fill out any information about shirts. So Sean mentioned a couple times in the last few meetups that we have shirts available. So if you were looking for, we're just trying to collect which one makes the most sense to print or which ones make the most sense to order. That's funny, it still shows the stuff like that.
So does this start at 6 or start at 6:20?
Oh, there's Savio. Hey, Savio.
Okay.
So yeah, we're using this new app called StreamYard, which allows us to stream to YouTube. So right now we have the YouTube link live, so people can watch. We can see the chat as well, so people that are there can post comments and stuff like that. Right now, it's just the three of us here. When I actually go to start the presentation, I'll just take over. You guys will be put on the sidelines, and then as you're ready to present, I'll click you to queue you up. You can take over, and then you can share your screen. One thing the app says is that it's nice to have two screens, but if you don't have two screens, it's perfectly fine. Just keep in mind it'll cast an entire screen. Unlike Hangouts, where you can cast one tab at a time, you can't really do that in this app.
Okay. Yeah, I don't have a second screen available for this machine right now, so, but I don't know.
Yeah, that's fine. We're all good. I guess that's a little different from the Hangout we did last time because everyone could talk at the same time. But this time it's really just people watching. So it's maybe a little less audience participation, but I think the setup for the presenters is much more clear, especially because we have other people presenting. Last time it was just me. So
Nice. And actually, this is the first time you're using this app then? You didn't use it before, or you?
Yeah, Sean found it a few weeks back, and he said, let's give it a shot for the next meetup. And so this is our first time giving it a shot. It's called StreamYard. So they have a free account that lets you do the basics, and then if you want custom branding and a couple other fancy features, you can pay to I think it's like $20 a month, which isn't too bad. If you're doing a lot of streams, I could definitely see that being super useful.
Yeah, not much. And does it? Oh, actually, it only shares the entire screen, right? Okay.
It shares the entire screen. Right now we have the video set as unlisted just because we'll wait until everything's done, until we put the video live, and it'll just be a public video after that. So I think in hindsight, I should have made it start a little bit sooner from 6 to 6:10, but I think I survive.
Hey, I found out that you have been playing with Suol too.
Yeah, I was updating a repo from a while ago because someone was complaining that it didn't have all the examples completed. But it was an old repo that I had created, I think, last year, and then I never figured out how to get the other examples going. But then after like 2 hours of finally putting my head down and figuring out, okay, how the hell does this thing work? I finally figured out how to get that event stream example working, and it works pretty nicely. It's just a little bit more convoluted than I would have hoped, but it works.
Yeah, I didn't went through all yet, but I could make some very cool stuff working.
You can make some what?
Yeah, today some very cool stuff working. Like today, I'm just going to share about the WebSockets. Mm-hmm. Just one small example. But, yeah, I'm intending to move in the direction of multitasking.
Yeah. Yeah, I don't think I really did. Did I do any for multitasking? Not really. I did the process one, which kind of lets you do that. Because it doesn't show the examples in the order, I think.
Let's see.
The channel. Yeah, I think it was the channels too, because they don't even though you fill them in order, they don't execute in order. They're just. I think that's right. Yeah, hey everyone in the chat. If you post in the chat, we'll see it. That's really the best way to communicate with the people on screen at the moment. And if people have questions during their talks, we can answer them via the chat, or we can see the chat and answer it verbally for you.
Okay. I'm seeing like live comments. What is the private chat?
That's for us. So if I wanted to send you something, be like, hey, turn your volume down, or something like that, I could message you on the private chat, and it wouldn't disturb the rest of the audience.
And I guess they won't see my StreamYard screen, right?
No, they'll only see the screen that you present. So, I mean, if you present the screen with your browser on it, and StreamYard is one of the tabs in the browser, then they'll see that. Okay. But yeah, you don't have to do that. I would just say, you don't have a dual screen, so I don't think it's a big deal. Just open up a new tab if your presentation is a tab, or, oh, he just disappeared.
He's back. He was like too busy closing tabs.
In the login.
You closed your tab?
It went to another tab, like actually another part of the same website, but without connection.
Oh, that's fun.
I'm trying to be able to comment in the live comments, but I'm not. Like, and there's a login.
You have to be signed into YouTube, Scott. You were able to comment, right?
Yeah, I think you have to be logged in through YouTube. The comment I typed was from within the YouTube chat. I have like the chat popped up. I think you can only see it, but you can't reply through the live comments.
Yeah. So I think, Savio, you'll have to be logged into YouTube and have the YouTube video open and then posting in there.
Oh, the YouTube. Okay, let me check.
Just be sure to mute it because you'll be hearing double audio.
Okay. Actually,
you can show comments on screen. So you can see I just shared a comment by Scott. So I'm going to hide that now. So this thing's pretty cool.
Yeah, another software I recently discovered at work. I'm not sure if you guys remember Slack used to be able to do control other people's screen and do pairing and stuff like that. Obviously, they killed that feature. So I've been trying this software called Tuple. Actually, it's exactly like a Screen Hero clone. That actually worked pretty well.
Oh yeah.
Yeah.
What's the name?
Tuple. Tuple.
So you can share your screen, and so it's like VNC with a screen share.
Okay. Exactly. Yeah.
Okay. Hey Fabio, we can see your comments. What's up? So Scott, are you just using a presentation, or are you doing some live coding or anything?
Just presentation. I was going to do some live demos, but I was like, oh, not enough time to prepare for that.
Okay. And then what about you, Savio? Are you doing live coding, or do you have a pre-baked demo you're going to showcase?
Yeah, no, just a demo.
Okay, cool.
I tried to put this to be 15-minute max.
Yeah.
But I think I could do even less than that, but yeah, just a pre-made example.
Nice. Hey Jihoon, we can see your comment. Hello.
Yeah, not everyone is as brave as you, James, to live code all the things.
Yeah, it's too risky. Last time I tried, I spent 30 minutes trying to find a bug.
Yeah. Oh really? That's why you have to turn off bugs in your code.
Oh,
you forgot to turn bugs off.
Yeah.
Yeah. Yeah, just don't write bugs, man. That's the solution to that.
Yeah.
Yeah. Yeah, I haven't been doing really any PHP lately, other than like playing around in like little side projects. So it'll be really cool to see what you're doing with Stool.
Yeah,
I think
today actually. Sorry, go ahead.
I was gonna say it'd be nice. I really want to use Stool in production at some point to see what it's actually like to get it running in production. Like see how it actually works.
Yeah, I was trying today. Like I used an example of how they are doing that with Docker file on their website. I put a Docker file, and inside the file, inside the environment, I put one service to start as a Linux socket, and I put the other connections to communicate and give tasks to the server via socket connection.
Okay.
The number of workers to work with it, it was pretty nice. Like,
yeah,
I could see the huge advantage that it is to work with Soul.
Sorry, there's a bug in my office here that I keep swatting at. But
did you turn that off?
Yeah, exactly. There's bugs in my office, not in my code.
Here's the contraire.
Yeah.
Yeah. Just a few more minutes, and we'll get started. And I'll just I'll boot you guys off. I'll take over for a minute, and then I'll pass it off to you when we're ready to present. When whoever's first. I think Scott, you're first. Just as a heads up.
Okay. Sweet. Oh wow, PHP Real. That's cool.
Oh yeah, yeah.
A true global event. This is.
Yeah.
And this is very interesting. Like, it's streaming on YouTube directly.
Yeah, that's pretty sweet.
Zoom, like, Zoom does that?
No, this is StreamYard. Mm-hmm. Like, we're using this StreamYard tool.
But do you know if Zoom does?
Yeah, I'm pretty sure Zoom does. Anything that supports RTMP, which is it's the protocol for doing streams. So like YouTube recently, I don't know if you remember, you used to be able to do a thing called Hangouts Live, where you could have a Google Hangout go straight to YouTube. But they killed that feature. They don't let you do it anymore. But now they support like really advanced RTMP features, where you can actually create this endpoint and then set up your stream to go right to there. And so things like Zoom and other chat apps actually just implement the like sort of share to like stream whatever you're looking at to YouTube. So it's very similar to how like Twitch might work. If you're creating streams, like if you're getting a lot more advanced, where you're like streaming multiple screens and stuff like that, or if you have dual audio, or you want to like loop audio and stuff like that back through other devices and stuff like that, you can do some pretty advanced stuff with the streaming stuff. So yeah, it looks pretty cool. I guess, I mean, it's in the last, few months, I'm sure that YouTube streaming has gotten like blasted with activity, right? Just pretty much every conference that was of any significant size has streamed over YouTube at some point. So
I guess.
all right, I think we'll get going here. So I'm gonna hide you guys for a second, and then I'll add you back when it gets to that point. Okay?
That sounds good.
All right, let's do this one. Yeah, here we go. All right. Welcome to PHP Vancouver Online Edition 2.0. This time we're doing it quite a bit differently. We're doing a live stream on YouTube instead of the giant hangout. The only disadvantage here is that we can't hear what you're saying, but we can look at the chat and see exactly what you're typing to us. So we have a series of comments in the video already. If you're watching this on YouTube, you'll see a little chat on the right-hand side. You'll have to be signed in, I believe, to actually contribute to the chat, but anything you type in there, all the presenters as well as myself can see that. So if you have any questions or anything, feel free to make a comment in there, and I can actually show the comment here on the screen. For example, like this, and you can see that, and we can actually respond to that comment if it's regarding a presentation or anything like that at any point in the chat. I'll keep my eyes on it, so if there's something there, I'll be sure to escalate that so that the person speaking can see those messages. Great, so let's get started. Welcome to PHP Vancouver Online Streaming Edition. It's July 2020, if you didn't know that. Twitter, you can follow us on Twitter at PHP Vancouver. If you have anything to say about the chat or anything after that, please use the hashtag VanPHP. You can use that for us to help find those tweets and retweet them and stuff like that. If you haven't joined the YVR Dev Slack, I looked recently, and I think it's at about 5,000-ish people. I think I took a peek at it the other day. Yeah, it's at 5,108 people right now. So that's a pretty huge community. So if you're interested in getting to know the Vancouver development community, Greater Vancouver area community a bit better, definitely check out that Slack. There's also a PHP channel in there. I shared a couple things today. Sean shared some stuff as well, so be sure to check that out, and you can find stuff in there. Our sponsors, so we only really have one sponsor, and that's our PHP Storm giveaway. So we'll pick someone at random from the chat. So be sure to say hello in the chat, and I'll pick someone at random to give the PHP Storm away. Just keep in mind, if you do win this, please use it. If you don't use it, JetBrains will stop giving us these giveaways to give away. So if you do win it, please use it, or give it to someone you know will use it, or just say, I already have PHP Storm, whatever, and give it up, and we'll give it to someone else. So just be a good citizen there. Like I said at the top, for people who weren't watching, we do have shirts that we're trying to make. Sean has a hookup that'll help him print some shirts for a much better price than we did a couple years ago. There's two different versions. There's the large logo and the small logo. There's actually a link to a form in the description of this video. You could find that. It's a survey. Just fill it out. It just helps us get an idea of who wants a shirt and what the numbers would be for sizing, as well as which model, the small logo or the big logo. All the information's in there. Just click the survey, fill it out. We're just looking for people who are interested, and once we're done, we'll just let everyone know like how many we printed and what the pricing will be. Like I said, Sean has a hookup, so hopefully we can get it to be a decent price. If we're really just use the money to fund the meetup. So for example, meetup, if you didn't know, to actually be a meetup organizer, you have to pay a fee every year. So I've been paying that fee personally myself on my own credit card. And Sean and I go back and forth paying it. So this is just going to help pay for that, as well as pay for anything else. If we have more streams to do, for example, I mean, right now it doesn't seem like things are going to be open for crowds, at least for a little while, or people's office. I don't think they're going to want strangers coming in there and having parties, essentially. So it'd be nice to have some more tooling that we could use to help make our streams better, just for the short term. So please fill out that survey. Like I said, the link to that survey is in the description of this video, so you can always just click that. All right, our fancy speakers. So we have Scott. He's gonna talk about how to model and create a data warehouse. And then Savio is going to talk about a web app with real-time features using Swool. So they both sound pretty cool. Online etiquette. So this isn't as applicable in this particular situation, but in the past when we were doing Hangouts, it was just people keep themselves muted. The presenters, I can control their microphones now and control their screens, so it's a little bit more of a dictatorship in this particular instance. But just keep things civilized if that's going to happen. Or if you actually ask questions in the comments, I can actually take your comment and throw it on screen. Just like this guy here, DJ, is from Richmond, so I can throw up your comment in there and people can see it. We can respond to it. So if you have any questions or anything like that, just ask them in the comments and I'll keep an eye on it, and then we'll pop them up at the end of each person speaking and at the end of the meetup itself. If you haven't been involved in any of our meetups, I want to say attend, but they're not really attending right now. But the goal of our meetups is we try to have them every month. Haven't been as consistent now, just based on schedules and stuff like that. Sean's actually not able to make this meetup because he actually had a trip planned to go to Whistler, so he's actually unfortunately not able to make it. But in this case, we're going to try to keep doing these now that we found a little bit more of a professional setup here for actually doing these streams. I think that this setup is much better. So I think we'll do something like this more often. It'd be cool to do some more stuff like this with more of an online spin on things. My mantra for this stuff is always learn something that can make you money tomorrow. So hopefully you'll learn something about a data warehouse or learn something cool about Swool that can maybe save you time, make you money, improve your skill set, and then later on down the road, that'll actually turn into something monetary. Now onto our speakers. So I guess I'll just jump back here. So we're going to start with Scott. So I'm just going to step down as the presenter, and I'm going to put Scott up so he can present his screen for us.
Sweet. Hi guys. Let me just get my screen organized here. Sweet. So yeah, when Sean asked me to see if I want to talk at the next meetup, I was like, sure. And then as I was thinking about what I want to share and talked about, and I decided that I want to talk about this, how to design and build a data warehouse. Since that's pretty much like the only thing I've been working on for the last like couple of years. And then that's the only project I've been working on primarily on a date like professionally right now. But I don't really see myself as like a data architect or a data engineer or even like a database expert. So pretty much just like a developer trying to ship a product idea. So I've decided to change the title of this presentation to how I designed and built my first data warehouse and kind of like share my journey and my experiences working on my first data-powered product. And hopefully you guys can learn something from my experiences and also gather any feedback and let me know if I'm doing anything wrong. So I'll just quickly introduce myself. My name is Scott. I've been coming to the PHP Meetup for just a little bit over 3 years now. I'm currently working as a technical architect at 145 Software on the data analytic platform. I've spent 8 years as a full stack web developer, primarily in PHP, in Symfony. And also in the last 2 years, my experiences has primarily been trying to figure out how to deal with all this big data stuff. And there's a picture of me and my daughter. This is to give you guys a heads up. I do have like a toddler in my house. So you guys might hear some screaming or my wife is screaming. You guys will know why. So to understand how I got involved with the project, first we have to go back a few years and also to see what 145 does as a business. So broadly speaking, 145, we are a software company that builds data collection and reporting tools for medical schools. And what that means is that we build tools to make sure students are getting the right experiences when they go to hospital for training, and also to see if there's any gaps in the learning they're doing on their curriculum. And ultimately, we generate reports at the end of the year to let the deans to see if they're teaching all the right stuff, how their students are doing. And at the very end, like once every 3 or 4 years, we generate a large report to make sure schools are meeting their accreditation standards. And that's sent off to whatever the accreditation body is in Canada and in the US. So what that meant is that we don't do any online classroom homework or handling tuition or even application for school whatsoever. And we purely help assess how students are doing and given at school, and also determine how school are doing as a whole. And as a result, one of the biggest pain point our customer has is that they have to rely on other system and pulling data together to really get a full picture on whether or not the student is doing well or how the school is doing as a whole. So yeah, almost 3 years ago, I was pulled into a boardroom with our CEO, a couple directors, and a couple product manager to brainstorm how do we move the company and the product forward. And on one hand, we could build product to fill kind of like the gap that I mentioned before for assignment, classroom, and examination as part of our offering. But at the same time, it's like building these product in other verticals that we currently don't do and have it to be good enough for our customers to switch over. It's also like a huge investment, a huge risk. So what we have decided on instead is like we decided on pulling data together from all the other systems that the school uses into one single place. and to generate reports on top of that. So instead of going to 3 different places to gather all the information, what they'll do is they come to our platform, and then they can get all the answers there. And we have decided to go after accreditation reporting first, since schools are required to do it every 4 or 5 years. And oftentimes they do it, it's like a 4 to 6 month process. So it's pretty much like when school go through accreditation, it's pretty much like an auditor coming to your work and start going through all of your accounting and expenses. It's like a very time-consuming, expensive process for clients. So we decided to tackle their biggest problem and the biggest expenditure there. And if we can do that like with a click of a button or have it all automated, then it will be actually pretty amazing. And another reason why we decided went with this route is like much like blockchain, like a couple of years ago, big data was also a buzzword that was flying around at that time. So it didn't really take much convincing for the board to approve this idea. And from that, a new team within the organization is born. I was partnered up with a product manager and 2 junior developers trying to figure this thing out. And like any other startup, any CEO or product manager probably has read this freaking book called The Lean Startup, and also bought into the whole idea of like Google's design sprint. What that meant is that you have to come up with an idea, build, validate, and test every 2 to 4 sprint. For in our case, it's like every 4 to 8 weeks for the initial prototype. So given that requirement, we began to start building and start validating idea without much research beforehand. So to start, like any other developer, when we face a problem, is to Google it. And if I type in like how to build data warehouse in PHP, this is pretty much what I got. Well, you get something, but this is pretty close. Like really quickly, we realized PHP is not really meant to be built for a data warehousing platform. But if I do more research, 2 obvious things that came up. To build a data warehouse, there's actually 2 main steps. 1 is to model your data, and 2 is to build the ETL pipeline, which stands for extract, transform, and load. And I'll get into each of those items individually a bit later. And then, yeah, given that our tech stack at the time, we're using PHP 7 on Symfony, we have MySQL 8 and RabbitMQ and data table and D3.js. And then with the lean and design sprint in mind, we didn't have the budget or time to do research or purchase any new technology. We kind of have to make work with what we got to start. To start on the project, we kind of decided to start on the data modeling because this is ultimately kind of like the end result to build the data warehouse, to build a database that answers the client's question. And then also this allows us to work with the product manager to start gathering requirements because without knowing what questions the client wants to get answers for, we don't really know which integration we need to start building and to gather those data and where to get those data from. So, so we started out with just figuring out how to model a data warehouse. So to design the database, there's really just 2 approaches. You guys have seen like the term OLTP or OLAP floating around. What OLTP stands for is it's an online transactional processing database. This is purely designed for transactional like inserts and updates. If you I guess like most of us are web development. So if you ever use any of the ORM file like Doctrine or Eloquent, then you pretty much already know and design your database in an OLTP fashion, where that is kind of it's more optimized for inserts. Yeah, it's more optimized for inserts and updates, like to really quickly in and out writing data. And when you query the data, you never really do it on like the millions and millions of rows at scale. You're probably just fetching like a page of data, maybe to like 200 to 300 records, or when you run like a really big query, maybe thousands of records. OLTP focuses on data consistency, and the data is highly normalized. What that means is like there's very little data duplication. When you have like a duplicated record, usually it will spin out to another table, have an ID, and then join on that table to create like a foreign key, kind of like what this diagram explained here. And on the other side, OLAP, this is mostly for reporting database design. Like opposite to OLTP, this is optimized for reading large amount of data, where inserts and updates is less important. Usually when you do an insert or update into the database, it's quite infrequent. Maybe you run like cron job once a day or once every few hours. Or even if you are trying to do like a near real-time or real-time data warehousing, this is like done in batches, and oftentimes it's like with 1 or 2 database connection only. You don't have to really worry about dealing with like 1,000 people trying to write to the database at the same time. So the data can also be modeled differently to reflect that. And the primary goal for this database is rather than designing around what the page or the application will do on the back end, the resulting data model reflects more of a question that the end user are trying to ask. This is a bit very high level and conceptual right now. So we're going to take a look at what that data model actually look like. So for a data warehouse, the data modeling process is often called the dimensioning modeling, and the outcome of that is called the star schema. And the primary thing to note about dimensional modeling is that there's 2 types of table. One of them is called the fact table, and the other one is the dimension table. And with the fact table being at the center of the schema. What the fact table contains are the measurable metric, in this example here, like if you want to see your sales data, then you'll have your actually numeric data, like the units sold and revenue directly in the fact table. And the dimension table are more on the attribute you want to search and group and filter on, and those are usually more text-based. And what's actually interesting about star schema and data warehousing is like, there's this concept called like a date dimension or like a calendar dimension, which means like you're basically creating a database record for every single date of the year. At first, that might be kind of like seems like counterintuitive, but what I learned is that it's actually quite useful because you can actually tag a date by quarters and year, or like for our case, this is actually really useful to identify a particular date with a semester and a academic year to represent like the student learning like time frame. So that's like actually a pretty neat concept that I learned while doing this. And what actually goes into the schemas is like in the dimension. Usually you're trying to answer like the who, what, when, where, why. And then for the fact, you're purely just dealing with like the how many or how can the data you want to be measured in. So an example would be for our case, like for a student taking an exam, our fact table contains like a score, like say, did the student answer the question wrong or like right or wrong from 0 to 1 to represent like the percentage scale. And we might capture like the answer C they answered in the multiple choice. And we might have a dimension table for person dimension that tell you who wrote the exam, and a course dimension to tell you like where the exam, like for what course the exam was taking place for. An exam dimension to represent the what, whether or not this is a midterm or quiz or final. And a question dimension to determine like which question is it and what is it out of. And this kind of explains the why, and then why did the student get that score that he does. And and then as like when you oftentimes when you, what we notice is like when you finding yourself like your fact table and dimension table, it's not really answering the question that you want. You like the first instinct is like, I'm going to add other dimension and join the dimension to that to make sure I get all the data that I need. And what you end up with is like a schema that looks like branching out from the start and a little bit more. This is called the Snowflake schema. This is oftentimes considered as like an anti-pattern to data warehouse design because it adds like complexity to your data warehouse, and then just like add more layers, which means like you need to do more joins in order to get to the fact record that you actually want, and oftentimes leads to performance issues. So alternatively, when you find yourself having to add more data into the dimension and doing too much aggregation or having to piece together data from other places and shove it into your fact table, it's probably better to just spun out another fact table and then having like reuse the dimension. Kind of like seeing here, like you have two different fact table joined together by the branch dimension and the date dimension. And these shared dimension are generally called conform dimension. And what that allows us to do is like keep everything just one level deep, and also like keep your data model much more focused so that's not doing too much where it's not intended to do. And and yeah, like, so this is like basically like the really high level view of like how you actually do data model. And after like interacting with the PM a few times to like set some constraints around, hey, we want to follow the star schema. We only want to go one layer deep. This is the model. This is the fact. Actually, afterwards, this is actually a pretty simple process. And I was able to hand this task off to the PM, and the PM were able to work with some clients and get some spreadsheet going to kind of model our data warehouse for us. And now we get into like the more technical, challenging part of the data warehouse, which is the ETL. And most of the developer will spend most of their time on. So ETL stands for extraction, transform, and load. So pretty obvious, self-explanatory, like pretty obvious on what that means. So basically, you're taking data from what source system, you're doing some kind of data massaging, and then eventually load it into the warehouse. So extraction is less interesting. Oftentimes, you're dealing with like different sources such as CSV. So in PHP land, we just use PHP Office to kind of deal with that, to process CSV and Excel files. And for database, PHP already shipped with PDO driver that basically connects to most of the database already. So the problem's kind of solved. And for REST API and some of our clients or the vendor which actually trying to integrate with uses REST API endpoint. So at that point, we just use Guzzle to make the request and handle and build our own OAuth2 workflow to kind of handle that. So pretty trivial there. And the last one is kind of like parsing HTML. Like some of the more interesting vendor, like the government national examination averages and stuff like that, we actually have to scrape HTML from their website to download like a HTML table and then process the data that way. And for that, we're kind of using Selenium and just the PHP default DOM documents to convert to kind of like automatically log into a site, click a feed button, and then download the HTML, and then use the DOM document to change that into the array. So this is like actually like PHP is actually pretty good for it, where like it offers a lot of different adapters to different things, and we're able to get that going fairly quickly. And then we get to the transformation. For transformation, there's like really basic stuff, kind of like just renaming column, or like when you get a data with like 50 column, but you only care about the 30 column, you can trim like just drop database column, and that's what I call trim. And then there's also pivoting, kind of like when you have a really, really wide table, like a CSV file, but with repeating columns, then we want to turn like a very wide table into a very long table so that we only represent the record once in the tabular format. And data enrichment is another common data transformation that we do. What that meant is like when you have like dealing with data from multiple sources, you might have data scattered across different vendor systems. For instance, for one of the learner information, you might have just first name, last name, email, but your student number actually lives in a different system. And we have to use like email addresses or kind of do some kind of string matching to match the two together to add additional data so we can have a complete view of like a learner information into one single record. Data aggregation, pretty trivial too. Like this is usually when you have to say find the class average for an exam. So you aggregate all the rows together, divided by the number of students, and use that to kind of do some kind of standard deviation mean calculation. So you calculate once rather than in real time to save you a lot of performance, and have it live in the warehouse is super useful. And just some validation to make sure like we're doing like making sure all the data integrity is there. There's how to deal with null value, how to deal with like missing data and all the other stuff, and how do you determine how to reject or allow the data to flow through your transformation. And just as important too is logging too. Like we want to be able to let the client know about why certain data is missing, or like where, as you go through the different transformation and filtering steps, like why did the data disappear? And this is like super critical in the ETL transformation layer, where that to tell exactly where the data issue is will save you a lot of time there as well. And all this is done initially with just a lot of for each loop and array map. So like, as you can imagine, we're just like basically dealing with data in batches of like 2,000 or 10,000, and just like looping through each row and then passing through different filter. And then we get into the last step, which is kind of like the load. This is just handling whether or not this is an insert query or update query. This is actually quite simple. All we have to do is check for composite key, whether or not it's unique. If it's unique, then it's an insert. If not, this is an update. And to kind of glue it all together, this is kind of like pseudo-ish code of what we have. It's kind of like we have a ETL class that kind of extract, transform, load, and then basically a run. Basically, this function kind of allow us to configure our data transformation pipeline so that we can have like the end-to-end result at the very end. And the run command is just basically a check to do run in the while loop, where like a while loop, so that so we can keep fetching data until we exhausted the source and knowing when to quit. So this is all very trivial, and this is all like our very first pass on what we did. And at the end, we were able to kind of like glue together like a first data model with some using like D3 and data table. We were able to create a prototype that looks like this. And given a few iteration of it, we create like a couple more dashboard using this approach. And we were able to do some client validation and to kind of like validate, OK, client want this, we can move ahead with this. However, after doing it like a few times, creating a few dashboard and a few more data model, we realized the product is validated and it worked well in development, but it doesn't work at all in production. And I'm going to get into why. So what didn't work? As you can see from the code here, our ETL is a monolithic process. It's basically just like a string of different commands that runs in series together. And what's bad about this is, first, like extraction layer takes way too long. So like we have some vendor where we're extracting data with, like, say, 20 million rows of records and using a REST API, querying like 500 batches at a time, and with like average response of 1 second for each API call. The whole extraction process actually takes over 16 hours. And because of this, all the problem kind of propagate down the chain into the transformation and the load layer as well. And also, like a bug in the transformation, if you can see here, like in the code, like transformation runs immediately after the extract. So a bug in the transformation cannot be fixed unless extraction is rerun. So what we notice is we run into a few classic simple bugs, like how do you deal with null versus empty string meant complete different things in a warehouse. So sometimes like we ran into those bugs and we accidentally dropped a table in the dimension table. As a result, we're getting like foreign key errors and accidentally dropping like thousands of rows in the fact table as a result. So like we can quickly patch that, but to roll that patch out, we need to wait another 16 hours for the extraction to be done, and in order for the data to show up properly. So this is like really killing for ability for us to deploy and fix things quickly. And yeah, and also like using PHP for using like for each loop and while loop, like and PHP arrays in general, you're really just like processing data one row at a time. And this is like a bit too slow. As I mentioned in the earlier slide, when we do the loading part, we're checking against like, is this row actually unique or not? So we have to do like 12 million queries to check like, is this row unique? Is this row unique? Is it insert or update? This is actually very resource intensive and actually taking a lot of our time to process the data as well. And lastly, too, like handcrafting visualization using D3.js and like data table is not really sustainable, because we notice really quickly, like clients want to see the data differently. Like they want to see it as a bar chart versus like a dot, or versus like they want to see it horizontally versus vertically. And they want to not to put green, yellow, red on things, so that they all want to see the data differently. So to cater to that, it's a lot of resources to kind of like just cater to that. And at the same time, yeah, like we only have 4 developers right now, so this is kind of unsustainable. So this is getting into how do we actually solve this? So we have to, so at this point, like the product's kind of validated, we have to decide whether or not we want to build our way out of this situation or buy our way out of the situation. And as a result, we decided to buy a BI tool, mainly just purely for the reasons stated before. It's like we don't want the team to be spending more time on creating visualizations, and the BI tool could be really easily managed by somebody with some like Excel experience to really just like plot things out. And like, yeah, like, and this is like essentially like building a visualization tool is already like a solved problem that we're not really shouldn't be solving ourselves as well. And we kind of landed on Qlik as our vendor of choice, primarily due to just like they were offering a better price compared to Tableau and Power BI. And secondly, too, they handle like the multi-tenancy that we need as a requirement to be able to have multiple organizations live underneath the same instance of the application. So that's worked really nicely for us up to this point. And on the other hand, we decided to build our ETL mainly because no vendor really allow us to implement really complex logic. When I was like looking at ETL tools like Informatica, Talent, or Pentaho, what they really do is like really focus on dealing with data that's already in a tabular format and its ability to like ingest like petabytes of data and then try to do like process and like really for like almost like for like internal businesses where that most of the data lives in the file format or already in a database somewhere. And secondly, too, like no ETL vendor actually like will implement like kind of like the web crawling logic using Selenium and all that stuff for us. So like no ETL tool can do that for us. So we decided to build our ETL tool. And to build our ETL tool, we decided to use Apache Airflow. I gave a previous presentation about this a couple months back. What Apache Airflow is a like a workflow builder. Basically, this allows us to really programmatically design a very complex workflow and then basically allow us to schedule and visualize how your workflow is. And I'll give an example of that a bit later. But then this is what we decide to do, like decide on as a technology to use to orchestrate our ETL processes. And secondly, the second problem is extraction takes too long. And our solution for that is to just basically come up with a better data policy. Sometimes like the best solution is the one that doesn't require any work. So what I did is like instead of part of the reason why we have to extract so much data is so that we can get data updates. Yeah, so what I'm trying to do is like actually to get the try to get all the data updates and insert and deletes. And what we notice is like most of our data actually doesn't get changed very much at all. So you can see as an example here, most of the time we're only seeing kind of like data updated. It's actually the data deleted is actually really low percentage of data is actually getting changed most of the time. So what we did in the end is basically work with the client, talk to the product manager, say, hey, we're only ever going to keep 3 years of data up to date, and the rest of it, if you want to update it, then it's going to be a manual request. So that kind of made the problem go away, and we're able to reduce our ETL runtime from like 16 hours down to like 35 minutes just by doing that alone. So that's pretty sweet. And second problem we have is ETL is a monolithic process. So what we did in that is like instead of just doing the literal extraction, transform, and load, we actually evolve our process more into like a ELTL or ELTLTL, which that means is like every step of the way we're caching the data into some kind of interim database, just so that every step could be replayed without needing the previous step. So as we extract data from the source, we just basically take the source, dump it directly to a processing database, and we transform, and then we dump it into another database just so that we can play back as often as we want. This obviously has like added to a lot of the cost in terms of like our hosting and stuff like that, but at the same time this speeds up development and ability for us to diagnose problem, and also solves the problem of sometimes like one of the vendors decide to update or it went down, we don't need to rely on their data to be present all the time in order for us to do the work that we needed to do. And what we also did is like we break each of the tasks into a separate process. And this is where Airflow really comes into play. This is a bit small here, so I don't expect you guys will be able to read this, but each of these blocks here are individual processes that's either doing extraction or transformation or loading steps. So Airflow really allows us to kind of like group it all together with all these crazy arrow dependency and really sequence it to let us know if something goes wrong. Like anytime like a job failed, it'll turn to red, and Airflow gives us the ability to like right-click on one of these jobs and restart, and then that will just pick up the job from there after we have applied a patch or understand what is going on. So this is where like this is kind of how we break up into multiple different processes for our ETL and secondly, and then kind of like the problem is like the processing data is way too slow. And so what we have decided to do is we have decided to move our data processing from PHP in code to SQL as store procedures. And in order for that to work, we basically create all our store procedure as .SQL files into our code base, so we can check in and see all the logic changes. And also we change our database migration, document migration in this case, we extended it. So every time we do a document migration, you'll actually look through like a folder with all the stored procedure with .SQL file, drop the existing one and apply the new one. So that way we can actually have some kind of version control with our stored procedure. And for those of you guys that never watched store procedure before, store procedure is basically like a function you can create in your database. And you kind of start by doing like create procedure, name your function, give it some variable, and then you kind of start scripting between the begin and the end tag, and your SQL code goes here. And to call it, all you have to do, instead of doing select, query, or whatever, you just have to call your store procedure, pass some parameter, then you'll execute your SQL script for you. So this is kind of like a neat way to kind of keep your logic closer to the data. And yeah, over like the last 6 months to a year, we have like migrating all of the logic from transformation from PHP to SQL. And that way we're allowed to do data, like process data in a tabular format instead of row by row. So this is like an example store piece on like what the store procedure looks like. It's basically creating a ton of temporary tables. And all we're really doing is like doing different selects and applying different transformation to it, like renaming, remapping, and then doing all the union joins across all the different temporary tables, and then kind of like join them together to match the schema of our data warehouse. So this is just like one example, but yeah, I have like an example that's way more complicated than that. So as we got to do that, like we solved the performance problem, but we also noticed some downside with using store procedures. So like using store procedure, yeah, like nice thing is like it's been around longer. Like a lot of the database admins actually use this technique for data transformation. It's good for handling large data volume. You just have to scale up in order to handle more data load or batch the data in the database to handle that. It's decoupled from the programming language and framework, which is kind of nice because we're not really sure if like we want to stick with PHP in the longer term for the product. So it's nice to be able to just move all the logic away from the code base and then live in the database, and we were able to like have it accessible regardless what framework or tools that we used to do. And also like because we're dealing with a data warehouse, and I felt like at the time like SQL scale is a must for us in order to support our client better. So might as well go all in on the SQL stuff if we are going that route anyways. However, on the other side, like the cons is that the database is not very easily scalable, meaning that it can only scale up and not out. So as we have more data, more volume coming in, then we are requiring bigger and bigger server rather than having distributed the work out to multiple servers. And what I found, like the tool set for SQL is very limited, meaning stuff like having to like purify HTML or doing some kind of like really basic function that we're used to do in terms of like just cleaning inputs from users I find it very, very challenging in SQL. And also logging is a challenge as well, because since we're dealing with data in the tabular format, then data is getting filtered out by like thousands and 10,000s of rows. So if you want to check exactly why the data disappear, then you have to explicitly query for it, which is kind of counterintuitive. You're doing a select to filter the data out. You do another counter select just to see why the data didn't get selected in the first place. It's hard to debug because there's no you can't really put a breakpoint on it. As you can see from the earlier slide, when the SQL script gets to like 1,000 lines long, it became impossible to debug or not easily unit testable because there's so much dependency on making sure all of the tables and all the required pieces are in place before we can actually write automated tests. And yeah, we oftentimes we actually really test the limit of like the MySQL engine to actually have to know how everything works in order for it to optimize properly. Like I think once we do a transformation, like just wrote a SQL query, but we didn't index it properly, then the whole SQL query took about like 16 hours to complete and then brought down like our production server, which is kind of bad. So we actually have to understand every single feature and how to optimize for it. Like when you have to do like recursive function within SQL, I think that's where I draw the line in terms of like, okay, this solution is getting a bit too complicated. And as I found out too, like myself included too, we do not find this experience to be very, very enjoyable as all the cons stated above. So this is a problem I'm currently still investigating on how to solve. But if I found out how I solve it, I might give another presentation about how I solve that particular problem. So yeah, so this is kind of like a summary of like the last 2 years of what I've been doing. And then where the product is at right now is like currently we have 7 different data models that, and then we have built 5 data vendor integrations. We have 10 schools in our pipeline right now, and then roughly handling 100 gig of data. So like this is kind of like where we're at with the product right now. So still very early phase. I think this year we're thinking about building a couple more integration and with like a lot more clients on deck interested to trying this out. So what's next for this platform? For the future, I kind of want to see if I can turn the ETL into like an ETLP, add a prediction to it, like do some kind of machine learning on the data that we've been spending so much time cleaning up and building. And yeah, really focus on scalability. Like I want to, because right now what we do is like we just throw a lot of horsepower at doing this data processing. What we like to do is like incorporate Docker and Kubernetes into the mix where that most of our servers are just kind of sitting there doing nothing most of the time. So I would like to have it so that using Docker to kind of, and Kubernetes to scale up the infrastructure to give as much raw processing power during the night when the ETL is actually running and turn that off when it's not there. And that could save us a lot of infrastructure costs there and also easier to scale once we onboarded more clients. And I would like to build like a general API to allow like clients to build integration into this warehouse so that we don't have to build the integration ourselves. The client has some vendor that we're not interested in building so that they can just use our API to dump data into the warehouse directly. And a couple of technology I'm currently playing around with is to incorporate like Apache Spark and Kafka to really deal with like really big data stuff. So this is like technology I'm currently looking into and can't wait to get my hands on it and learning more about it. So yeah, like this is a pretty long presentation, but I'm going to end it there. So at the end, yeah, please type any question or roast me if you guys want in the comments, and we'll get to it a bit later.
Cool, awesome. Thanks for the in-depth presentation. It was really cool. I'll give some people some time to write some questions if they have any. I will say, Scott, you can keep yourself unmuted because we do have a couple notes here. Yeah. We have the first thing from Kevin. The Scott fellow sounds really smart. So,
thanks.
And we have another legitimate question here, probably maybe less related to the actual details, but why Symfony and not Laravel for the PHP choice?
Mainly because our core product is purely built on Symfony. So like, so when I was like proposing on how to build the front end of it, I was like, do I want to blow everything up and do everything new from scratch? Or do we want to like keep some kind of integration going between the two company and the two teams? So that's why I ended up with that. And based on what we needed to do, it's mostly just like command line based, like all these transformation extraction you see are all just PHP commands. So it doesn't really matter what framework we use because we don't really use like the templating or any of that stuff at all. So I think it's mostly for familiarity, and also we can like bring people on board to our team to help out if like we're feeling like behind on the project, so we don't have to ramp people up again.
So at this point, how much of the project, like if you were going to hire someone new and they had, would you pick a candidate with more SQL experience or a candidate with more PHP experience at this point?
At this point, I think mostly in SQL, just understanding around how data works in general. I think that would be closer to that. We might hire PHP experiences based on our need to build more data integration with different vendor. But as you can see, like all the problems kind of solved. We're kind of exhausting the sources already. So yeah, there's less of that. But I think right now, most of our solution is kind of like, because most of our front end is built on this Click like BI tool. So yeah, there's actually no front end work at all for us, so that we're not even coding JavaScript at this point.
Okay, cool. So then another question about the stored procedures. I guess there's no like, how do you do error handling with like the stored procedure? Like what, is it just wrapped in a transaction?
Yeah, it is wrapped in a transaction, and it's like really, really low level. There's like a separate table you can create for really low level SQL query errors. That's how I handle it. Oh, and another plug here too. Another tool that I use to kind of help developing stored procedure is IntelliJ has this tool called DataGrip. It's like super great for developing database stuff. So if you win like the PHP-1 license, you don't want to use it, check out that tool. It's pretty sweet.
Oh, cool. Yeah.
So I'm using that actively to kind of like do the autocomplete or to know like, hey, what kind of functionality I have and to troubleshoot all of that stuff. And it actually allows you to step through each of the SQL query steps within your stored procedure so that you can see like the output of each step. So this is pretty cool.
That's cool.
Yeah,
what's it called?
Is super pain. DataGrip.
DataGrip. Okay.
Yeah, but it's super complicated. That's one of the frustrations we have. We usually just get like error none 1001. It's like, I don't know what that is. Or which SQL causes that problem.
And like, I guess you can't really queue the work for later, can you? Like once it starts running, it's running on the database, right?
Exactly, yeah. And then that's why we limit like the connections we allow to the data warehouse. So like we use like Apache Airflow to say, hey, when we do the loading or transformation part, we limit it to be like 5 pools of workers. So only ever allow 5 connection on the database running at any given time so that we don't just blow everything up.
And do you have, I'm guessing you have like replicants of the databases? Yeah.
Yeah, and then we do like a promotion model at the end. It's like only if the database is healthy, we're putting it to production. So like our loading parts, like actually at the end, we just get a SQL dump and then we just put it and do a swap.
Yeah. How did the project manager like, or how does the product manager deal with some of these things? Because like, obviously there's a huge technical hurdle to like adding features here when it's like, oh, I want to do this type of data or I want to get this information. It's like, well, who knows? That could be like the data isn't there, or it might take hours and hours to actually finish a query like that. How do you like communicate with your product manager? Because it's not like, I think most classic stuff would be, most classic sort of relationships between the product and this product manager would be like, oh, there's pretty much anything you kind of want to do, you can do. It's just like what's your tolerance for how long it takes?
Yeah, I guess that's kind of a nice thing too, because this is like very technical project. So a lot of the product management just leaves that planning to me. And then we kind of like really collaborate on like, okay, we built a data adapter for REST API already. So we probably have that workflow down. So if we choose a vendor, I'd much rather pursue the same one with like a data connector that's already there, rather than pursuing like completely different ones, right? So that's kind of like how we proceed with prioritizing that project, like prioritizing like what data vendor we go after. Yeah. And a lot of that stuff too is kind of like we basically, a lot of it is like a lot of front load planning. Like I spend a ton of time to like test out each of the vendor to see, okay, if I were to fully integrate with this is how long it might take. And just like a lot of proposal, a lot of documentation for sure.
Yeah.
Yeah.
Okay, we have 2 more questions. Savio says, I saw a mention of RabbitMQ there, but I didn't see where it was used later. Is there a RabbitMQ usage?
Yeah, so prior to Apache Airflow, we kind of using like RabbitMQ as just like a way to kind of tie all the dependency, all this queuing, like all the job, like say, do extract, transform, load, like just queue it up in that using RabbitMQ and use it like a scheduler to kind of say, hey, I want this job to run ever many times within the day. This is kind of like how we're using it for. But at the end, we just like swap it out for Airflow, where like it gives us like a more visual representation of exactly the same thing.
Okay. And then last one here, Doctrine is native to Symfony. Was it useful in this project?
Yeah, it's useful in the way that we have migrations so that we can like, because the version of the data warehouse changes so often, like we need to keep the modeling and roll back whenever we can. And and we are able to use like the migration command and extend that to build our way to deploy and like version control the store procedure stuff. Because most of the DBA I work with, they just use like MySQL Workbench or like PGA admin to like work with the SQL like store procedure directly on the database server, which is like invisible to the devs. So that's like a big no-no. So I just like, okay, we can figure a way out how do we deploy our store procedures.
So they might work on the store procedure in the Workbench and then copy and paste that into .SQL and commit that and then deploy it.
Exactly. Yeah.
Okay. Yeah. Cool. All right, Scott, thanks so much. I'm going to boot you off here. And then next up is Savio. So Savio, if you want to share your screen right now, that'll allow us to me to set up the layout for us here the same way we had for Scott.
Right there.
Okay, there we go. So I'll jump off and I'll let you take it away.
Okay.
All right. Good luck.
Thanks. Well, my presentation is going to be way smaller and simpler, actually. This is not an actual production product, but let's go. This presentation is going to be about SWO, which is a PHP extension for multitasking. So let's go ahead. My name is Savio, first of all. I'm a PHP developer for 30 years now. I'm originally from Brazil, but I lived in Vancouver for 3 years, where I had the opportunity to work with Sean and James. And then I moved to Ontario, where I am right now. So the fact that this meetup is happening online gave me the opportunity to participate. And this is actually pretty cool seeing old fellas online again. So let's do it. First of all, I'm going to talk about like what PHP is. Is everybody ever worked with it? We're going to go through some advantages, benchmarks, and an example web, something around 15 minutes max. What SWO is? SWO is a PHP extension. You can find more here about like in the PHP manual about like how to install or something, or here. Here is the official website where they explain more. They have further documentation, and they have articles going out very frequently where they go over subjects like how to handle exceptions with SWO, which is a little bit different than usual exceptions on the usual PHP environment. For example, if you are dumping variables on SWO environment, is a little bit different. The dump data is going to be shown in the command line, for example. If you're running your environment on SWO server, of course, like if you're just using SWO, like if you have SWO installed as an extension, just to use the other features, it's not going to work like that. But this is basically how SWO changes the behavior of PHP. There are way more things. For example, it allows coroutines on PHP programming. So you can asynchronously start tasks you can delegate these tasks to other process, to other workers, and continue some other part of your code. When you're done with that, you can go and wait for what you delegated to another process, goes back, continue the code with the data from there. You can see like how that can help with the PHP performance, right? For example, I'm going to go over that on the benefits, but it's worth it to mention right now. Slow, by allowing this, allows other types of programming. I would compare it with Node.js because, for example, you can start your own HTTP server, your socket server, your Unix socket server. You can start a server for MQTT, if I'm not wrong the word, but to work with IoT. You can keep the communication between these processes via socket, and it's way simpler than it was before. Actually, I knew that there was some kind of socket with PHP before. I never tried, so if there is anybody out there that ever worked with that, please say something at the end. Yeah, that's how Slow changes everything. And the best part, Apache license too. So that makes easier to work with, right? So advantages. You can build web applications without a part of your stack, which is web server. And that has like a huge benefit because usually, I think we all know here that PHP is a single threaded. So everything you ask PHP to do via code, what is actually in the background is that PHP is doing one thing at a time. So you say like PHP does these three things and it goes one by one. With Slow, you can put a different worker to do each one of those tasks and gather everything at the end. It's going to save, let's say, maybe it's going to do everything like 2 times faster, maybe, I don't know, depending on the tests, right? So it can be very beneficial. It also adds more complexity, of course. It changes a little bit how you're going to develop, but anyways, like now you have the choice, right? You can build real-time features. I know that we have now the React PHP that also allows that very easily, like all, but there is a difference. And the difference comes to what I just said, which is the fact that PHP without Slow is single-threaded. I didn't try React PHP yet, but I guess it's not changing there because I think it would need some C-level code like Slow does by being an extension in order to achieve that with PHP. So yeah, I consider that like a huge advantage on Slow side. And consequentially, increased performance with coroutines, just like I said, and better usage of server resources, which is a result of being able to delegate and use more processes at the same time. So if you use, for example, htop to check the processes of your machine, instead of being like one PHP process there, you are going to see, for example, let's suppose that you are using Slow and 10 people access your website on Slow at the same time, and the process takes enough time for all of them to be at the same time in the server. You will see 10 processes there. So this is something very interesting. It uses better the resources available. So, and this is the why. I didn't get enough inside the understanding of how the whole thing of reactor, manager, and worker, but this image gives an idea of the change of how things work with PHP. So I just wanted to share this. You can find this information, more information here, if you are curious about it. So moving forward, benchmarks. So I built some benchmarks. I ended up finding actually, in some cases, bigger differences than this one, but I prefer not to bring mine. I prefer to bring one because I didn't have enough, I didn't spend enough time on these benchmarks to actually write an article about it. Here's an article that you can go check, read, and understand further the motivations and the findings of this benchmark. But here is an example of a Lumen application running on Nginx, and in the other side, running on Swole. And the difference is huge. Like on Nginx, the Lumen application can receive 80 requests per second. On Swole, 8,717. So it's a huge difference there. So I hope that this kind of cause some impact to some people here. Let's move forward. Then now the example app. I built a very simple app just to explore the benefits of using Swole and what I could achieve. So this is the repository. You can find it here. So let's go there. First, let's see how we organize the code. So I used, actually, let's go to the dependencies. I used for this Slim framework. I'm using the version 3. I tried to use the version 4, but I'm using a library to actually match the requests the way they come from Swole, the HTTP request, with the request the way they are expected on Slim, which is PSR7. And they end up having a few issues there. So I think there are some tweaks to do there. I didn't want to spend time there. I just wanted to make this work. So I decided to move to Slim 3, which is a version that I actually had experienced before. And of course, Swole extension I installed in my environment, PHP unit to do my unit tests, PHP leaf file supply system. The reason for this library to be here is because, just for a matter of curiosity, I decided to use file system instead of a database. Just for your information, Swole also has some functions, extra functions, actually a driver for PHP and MySQL. So instead of using the usual PDO, you can use the Swole MySQL functions. I think it's a little bit different. Never tried or read further, just they exist. And if they exist, they should exist for some reason, right? And for a small application on the UI, I decided to use Alpine.js because I never used it before, and I'm very curious. So the way I organize code is like this. Everything that is here is about configuration. For example, I'm returning a function at the end of the file. I'm passing the container of the application, and I'm putting in the container the actual dependency that I have there. I have another group of dependencies where I actually adding more stuff. I think this monologue.
Could you just bump your font size a little bit, just so we can see a bit better?
Of course.
Just a couple. I think maybe like two bumps. Two bumps. Command plus.
Command plus.
Yeah.
Okay.
Yeah, that's great. Perfect.
Okay.
Yeah, nice. Perfect. Thanks.
So I think I have I just found a duplication here, but yeah, this will find every time I show my code live, right? I will find something. So there are some dependencies here. As you can see, the fly system, data driver, which is actually a small code that I wrote to wrap the CRUD process with file system stuff. And I end up writing a socket handler. And the purpose of this socket handler is actually to be able to receive a socket message and do some action with it. So I'm actually expecting a pattern on the message via socket and do something with it. For example, if you receive like a post request from your API, on your API from a client, you're going to expect like the body, right? So you're going to expect the body is a post HTTP verb. So you know it's creating a resource, and then you're going to do something with it. I'm doing the same thing, but socket, I'm actually passing the verb in the message. I'm encoding as a JSON. So if you go like in the index, let's go with the code flow here. So I added the dependencies, the app settings, and then because you start the server on the command line. So if there is an argument, I know that this is very extremely simple, but if there is the first argument, -- WebSocket, I'm going to start the WebSocket server. If there's no, just HTTP server. I did it just for the purpose of the simplicity here. And I'm using the same code to create both. And if we go to the WebSocket server, you'll see that I'm watching for the socket events. So this is how you create a socket server with Swole. You extend the main classes of Swole, and you start the server just like this. It looks a lot like Node.js. And then you listen for the events that happen on the server and do something with them. So start, open, I'm just echoing in the command line. On message, I'm doing something different here. So if you remember in the dependencies, I'm actually adding the socket handler like this, and I'm accessing them right here. And what I'm doing is I'm getting the container, and then I get the socket handler, and I evoke it, like I run it as a function. So if you go in the and then I dispatch for everybody who's connected the result. That's what I'm doing. So if I receive like a message like add this data, I'm going to add because the socket handler is going to do so. And then the result is going to be pushed to everybody connected. That's what I'm doing here. I'm getting all the connections, I'm looping through them, and I'm pushing the response as a JSON encoded text. In the socket handler strategy, I did an example here. What I'm doing is, actually, there's an abstraction. So when you instantiate, you add a container, of course, but actually when you run as a function, you run this magic method here, invoke. And what I'm doing there is I'm running the parse data, which extracts the action, an instance of the action, and then I'm executing the action here. So if you go in the implementation, you'll see the parse data here, and I'm returning an action after that. So I validate the data, I add the model here just because of the dependency injection here in the action. Depending on the action mentioned in the incoming message, I'm instantiating a different action. So these are the actions that I'm actually expecting. I'm expecting like the crude actions, right? So if you go to the actions, you will find those actions that I'm actually implementing here, and you'll be able to see what I'm actually doing there. For example, in the create, I'm just creating. I'm running a create in the model, getting the ID. It's if this fails, I just run an exception after. If this works, I get it and I return the resource. That's what I'm doing. And I'm doing this via socket because I wanted to explore how it would be doing this via socket instead of an HTTP API. And that's what I'm doing. So in the UI, I build just the create, actually. I didn't stop to do further, but this can show what I'm actually doing. So I'm using Alpine.js, right? And this is how Alpine.js actually deals with the data in the state of the application. So I can change this to do by throwing an event here, or I can load it with the data, right? So what I'm doing is I'm loading it empty, and I'm bringing data via event. And this is when it loads. So when you load the page, what I'm doing is right here. If you go to where I'm throwing this event is this. I'm actually throwing this parse data. Actually, when I open the connection, I send a get. This is what's happening. And the result of the get that I'm doing there is when you don't send any filter with the get, is that I'm returning everything, because I wanted to keep it simple. And when I receive the incoming message, I just parse the data and put in the to-do loaded. So everything that comes back from there, I'm going to put like this. I know that there might be some possible issues. This is just for the purpose of this presentation. I'm intending to move forward with this to prepare Barry's skeleton for this cycle of updating data with socket, because I'm very curious about where I can get with it. So when you add an item, you're going to receive the data. If it's not an array, it's a resource. I know this is a very poor way of doing it, but I'm doing it because of the simplicity here. And when it's a resource, I'm just adding it. I'm not expecting the delete yet. I'm not expecting the read a single resource at this moment in this UI. And as you can see here, I'm just connecting to that socket server. And then like for every input, I'm listening, but if it's an enter, I consider that you're actually wanting to submit the input. And then I add the item. By adding the item, what I'm doing is I'm sending the create verb with the content of that input. Oh, okay. I'm adding, I'm sending the content of that input to the backend as a message, and I'm emptying the field. So let's see it's working, right? So if you see here, for example, when you add an item, you'll have that event thrown here, right? And when that event is thrown there, we push the new item here on everybody. So for example, the client A sends a new item, everybody is going to receive the new item. So I'm not adding the item in here where the client A is actually dispatching. I'm waiting. The client A in this case is also going to receive the message in this case here. So yeah, the rest is just simple HTML, and this is how we loop with Alpine.js. Simple stuff, very simple. So the way I'm going to run the server, actually, is there a way for me to grow this without going out of the screen? Okay, like this. I hope you can see my screen, like read well the command line. So the way to run the HTTP server is going to be just this, HTTP server running, the socket server. Oh. Okay. The socket server is like this, WebSocket, -- WebSocket, and now I have both running here in different ports. If I go to my browser and open localhost 8282, there it is. So what I'm going to do is I'm going to shrink this, and I'm going to open it again right here. So let me actually grow this. And in the back here, you'll see actually here, I'm already seeing some errors, but let's ignore them until I actually see something happening wrong. So, yep, working. So you can see here, probably these errors are because I was changing a few stuff before the meeting, but yeah, this event was thrown in the to the socket server. I'm echoing there what is actually being received at the first step. If you go there, you will see that happening right here. So I'm echoing the actual data, the literal data that we're receiving there. And this is how it was. everything was parsed, persisted. So if we go to the data, like for example, if I open another tab here, actually, it might take a few seconds. The machine is very overloaded here. So if we go to the data directory where I'm keeping the data, the file is there. It's just a JSON file, right? So if I go there, I can add like another from here this time, and it's there. Everything working. So yeah, that's pretty much the example that I wanted to share with you today. If you want to know more, I will share these slides link in this project. Yep. So this is pretty much what I was here to present. Is there any question? Buddy?
Sweet. Yeah, we'll give some people a chance to ask some questions. I would say, I guess you must have installed the Swool extension natively into your PHP, right? You didn't use Docker?
Yeah, in my machine. Yeah. Yes, actually, I didn't use Docker. I would actually, let me get it here. I would use Docker, but I'm having issues with my Docker on my Mac.
Yeah.
Actually, what I want to do is this. So I have Swool right here. So I installed right there in the raw machine. I'm having issues with Docker because actually not if I run in a single container, but when I need like connection with a better networking, for example, I put my SQL in one container and I have the PHP in another, it becomes a little slower than it used to be. And I didn't stop to actually go through it. I found out that other people were experiencing the same, so I just decided to do this example like this to make it faster.
Yeah. Yeah, just for people that don't know, Swool needs to be installed as a native extension like mcrypt or ImageMagick. So yeah, it can be a little bit tricky to get your hands on the extension and then build it and blah, 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 blah. But yeah, there is a speed penalty when using Docker for that stuff.
So you can, if you go to the website, they have like, if you want to try out the Docker, they actually have here, try Swool with Docker.
Mm-hmm.
So they actually have like the Docker image for you if you want to try it out.
Nice.
With PHP 4, that's pretty nice actually. I've been trying using this.
Yeah.
I got very successful actually. I didn't try this time just because of this issue I just mentioned, but it's very nice.
Also, when you need to run two processes, it can be a little trickier.
Yeah, to install, right? Like you have to compile depending on your environment.
Well, I mean, like you're running a server on one, and then you're running a WebSocket server on another tab, right?
Oh yes, that's what I'm doing.
So how come you didn't start two servers in your index PHP? Like, why not just start two at the same time? Because I mean, they're on different ports. So
I thought about that.
Yeah.
But, I didn't stop to try actually, so that's a very good question that I don't have the answer. I might try later.
Yeah.
I could start them silently, right? Just keep in the background, go ahead, start the other.
Yeah, I think we were talking earlier before the stream started, or before we started, about the example project that I had. And in the WebSocket one I'm doing, I have one server. Yeah, I have one server, but it handles both types. Oh, no, sorry.
Both ports?
Yeah. It starts a WebSocket server, but then just uses regular like file system to like serve files. But yeah, so let's jump to the questions because we have a couple here. Scott asks, how do you authenticate a WebSocket connection using Swool?
I didn't get there yet with what I saw, so probably I will do. Actually, I don't know. I won't go further there because I might say something that is just a guess.
Yeah.
So
I assume you could use a cookie, but I don't know. It's a different protocol. So
yeah, it's a different protocol.
So it's not like HTTP where you can just send cookies and request response and blah, blah, blah.
Yeah.
So,
because it's a TCP, I would guess a lot of stuff, but let's just keep like that. I will check. I will check further, and I will keep like adding stuff here as soon as I have some authentication layer.
So you're gonna add some stuff into that. You're gonna keep adding stuff into that project.
Yeah, I created a small to do here, like prepare HTTP, because like I only prepared the socket handling for the CRUD operations. I want to add like the entire CRUD, and then I want to negotiate better because, for example, if I want to communicate differently, and for example, I was talking before this meeting about the events, right? The event loop.
Yeah.
Because Swole has like an event loop where you can actually start a TCP with Unix socket, and then you can communicate with that TCP. And the advantage of that is that you can delegate like in a separate process of your machine, like multiple workers to do like a heavy job. And then you can like leave your server doing whatever it needs to be doing, like listening events, dealing with all the basic stuff while those workers work. And then like when those workers are done, I would like, for example, to do something else, to connect, to add through another path of data. So I was thinking about like being more flexible and being able to receive like also for the same processes a simple HTTP API. Finalize like data cycle. I have like remaining CRUDs on the UI and do a better presentation too.
Cool. Yeah, that sounds good. I mean, obviously you're learning and you're adding stuff as you go. So if people want to keep an eye on that repo, you're going to share the link after, right?
Yeah.
Yeah, cool. So we have another question. In production, how can I keep the service running? Would you need to use a supervisor?
Yes, you will need to use a supervisor because the Swole process can end like that. Every process can die, right?
Yeah.
So the way I did was in my Docker container actually, when I try to put like in a specific server is not a production server. I'm not doing that yet, but I'm intending to. So in my attempts, I actually create like this is actually a good opportunity to share this too. If you go to Swole organization on GitHub, you will find a lot of resources there. This is their source code, and this is their library. And in their library, they have like a bunch of cool stuff that I think is worth it to share. Actually, the examples, yeah. So, for example, something that I didn't know before, I end up like learning later. You can run like a WordPress via proxy. So if you have like WordPress on a PHP FPM Docker container, instead of like having an Nginx, you can have Swole just proxying to that PHP FPM. And this is logged all here, but let's go back to the subject. In the Swole, to run as a supervisor, this is the best resource that you can find on their organization, Docker image for Swole, and they have this strategy of having this root file system being copied to the image when you build it, and this actually adds the supervisor for you.
Okay.
So you'll find, actually, it's somewhere here.
It's got to be that conf file.
Yeah. So you'll find they are just starting the server PHP. This is how they do.
Okay.
I just copied from here when I was building my own. So yeah, this is the best option you have to follow.
Yeah.
I think.
Cool. Yeah, it looks like it has everything you need to sort of get started, at least with Docker. And I guess, I mean, if you're not using Docker, you basically have to recreate those steps natively on whatever box, whatever your server is running.
Yeah.
So if you're using, say Ubuntu, you'd have to make sure that everything that was in that Docker is now natively installed on the machine, and then add your supervisor and all that fun stuff as well. Yeah, I haven't used it in production yet, but I think it'd be cool to use. I've written a couple things with it just because I've actually found that because it has a built-in server, it's been really easy to get stuff going. Like the Docker image I use, it's just a very small one. It's not. I don't even think it's based on the official one, the one that I've been using. But it's very slim, and that's just it's just like a very basic one that just runs because it has a server inside, so I don't have to worry about what my PHP on my file system is or my base computer is actually doing and which extensions are installed, and I can just throw it up on GitHub and then Docker Compose run or Docker Compose up, and it just goes, and that's pretty sweet.
Yeah.
We got some more questions here.
Oh, just one parenthesis here, because it's worth it to share the problems also, right? I heard that there's a limitation on Swole. I was searching for it, and I found out that they have this limitation right now of 2 megabytes when you're uploading files. Via Swole server. So I don't know if they fixed that yet, or if actually this is not a fix, this is just an enhancement, a needed enhancement, right? So they have this limitation. So what they are doing right now to work around is that they are uploading multi parts. They actually splitting the file before they upload.
Really?
Yeah.
Huh.
I found some people talking about that on the Swole.
Yeah, that's a tricky one. I guess if you're using, if you're writing a serious application, you're probably using a CDN or something like that anyway. So I would assume that you're probably not handling uploads natively, but for most smaller or middle tier apps, you definitely would want to make sure your file it could handle file uploads.
Yeah. So this is an issue I found out. So I'm sharing. I don't remember where I saw this, but just to be aware, there might be problems there.
Okay. So Scott has another question or another statement. Looks like for WebSocket, what most people do is include a JWT as part of the message and make sure CORS is enabled. Yeah. The only thing with JWT is you can't revoke it because it's stored locally on the person's computer. So, yeah. But yeah, I guess there's a lot of different ways you can do that. Yeah, I've never had to authenticate a WebSocket. I've used things like Firebase and stuff, and they have different. Their authentication is slightly different because it's based on paths and not necessarily connections. But yeah, I'm sure people will find more stuff about Swole and authentication and WebSockets if they Google around. But it sounds like you're going to add an example of this at some point.
Yeah, I think you can use the headers, right? Somehow, probably JWT is possible, but I didn't try, so I can say.
Yeah. Cool. All right, Savio, thanks so much. If there's no more questions, I'll take over again and continue on with what we have left. So we're just going to start wrapping up.
All right.
All right, thank you very much.
Nice, thank you.
All right, where am I going here? Yeah, so I'm just going to wrap up. We didn't really have any sponsors, but we do have the PHP Storm giveaway. So I'll pick someone at random from our chat here, and we'll give away our PHP Storm license to that person. I'll send it just in an email or something. I'll mention you in the comments, and we'll do it that way. Be sure to check out the survey. There are 2 shirt types here and 3 shirt colors. So you have the large logo, black, white, and purple, or you have the small logo, black, white, and purple with a variety of sizes. There is a survey for you to fill out, so just go ahead and fill that out. The link for that is actually in our description for this video, so you can find it very easily there. Also, we have the link for these slides are also in there in that description. So if you wanted to see the slides, those are in there too. If you want to get involved or sponsor or present, just let us know. You can let Sean or I know if you know who Sean is or you're just familiar with me at this point. You can let us know. You can go on our Meetup page. Meetup is Vancouver PHP. So you can go there. You can message us there, leave a comment there. You can also find all the contact information that you need there. You can talk to us on YVR Dev, the YVR Dev Slack. So there's a million ways to get in touch. And also follow us on Twitter, or if you're going to tweet, make sure you mention us and use the hashtag VanPHP. Thank you, and see you in a month. So I guess I'll wrap it up because, I don't really have a great way to end this. So I'll just say thanks, everyone, for attending. I think we peaked at about, I think it was at 16 live viewers, so that's pretty cool. And if anyone's watching this in the future, I hope you enjoyed seeing the video and getting a little taste of the Vancouver Meetup, even though you're probably stuck in an office somewhere, maybe not even in Vancouver. So thanks very much, everyone. Bye.